Next.
So I'm live, right? So, okay. It's just All right. Good morning. Okay, we stopped on problem number 23. So when we worked on it, when I did it over here, okay, when we take the square root of x, the square root of x squared, it should have been x here. So we stopped here. So instead of this being x squared, this should have been x from yesterday. So now when you do it, so now you can cross out these x's. All right. Then we have 8 equals 4, the square root of x plus 4. Then we come here, we divide both sides by 4. 1 equals square root of x, but we know if we square both sides, x is just simply 1. And good morning, Selena. Did you all get the lessons? Okay, can you hear me? Okay. All right. So the 4 people that's on, can you see why this is the answer from problem number 23 from yesterday? Okay, good. Okay, so what I'm gonna do, we got to talk about radicals today. So we need to pull out your lesson 20, which is graphing radical functions. And good morning, the 3 of us. I thought it would be more, but hey. All right, so I'm going to go ahead and erase this. Okay. All right. So everybody have the lesson? Okay, so we're gonna look at example. So remember we had y is equal to x squared. All right, so when you're doing radicals, you're basically doing the inverse of your exponent. So remember how we did the inverse? We just simply switched these. So this is x, this is y squared. And so then y is going to be equivalent to the second root of it, square root of x, right? All right, so they're inverses of each other. But remember, we can only use positive square roots.
You want me to put it on assignment?
All right, so normally if we was gonna graph this, graph y equals x squared, it would look like this, right? Well, we know that when we did the inverse from previous lessons, it will look like this, but we're not going to use this. We're only going to use this part of it. All right. So what we want to do here, we're going to graph y is equal to the square root of x. All right. So y equals x squared and y equals the square root of x. They're inverses of each other. Okay. Now, so I want to graph these. I'm going to pick some points. Remember, we're only going to use the positive values. Okay, so we're going to come here, make us a ordered pair. And the best way to do it is try to find perfect squares. Okay, well, we know we can plug in 0, and the square root of 0 is 0. We know if we plug in 1, that's going to give us 1. Yeah, then what's another perfect square? Can't we do 4? That'll give us 2. And then we could go to, so what's another one? 9. And that will give us 3. All right, so if we graph this, it should look like this, like on your lesson. So we have 1, 2, 3, 4, 5. Then we have what? We do 1, 2, 3, 4, 5. Okay, so there's 1, 2, 3. All right, so when we graph this, we're going to start here. Because remember, if we let x, if x is less than 0, we'll have imaginary solutions. So the lowest it could be from the lesson from yesterday is going to be 0. So then we'll do 1, 1. And then we can do 4, 2. And so since this is a continuous function, it's going to look something similar to this. And so this is also your parent function. Okay. Any questions on this one? Okay. Are there any questions? All right. So if we don't have any questions, I'm gonna go on to the next example. Everybody's quiet this morning. You was talking a lot yesterday. All right. So I'm gonna go ahead and erase this. So we're going to do y is equal to the third root of x. So again, this is your parent function. Okay. All right. So just like we had to find perfect squares, now we got to find perfect cubes. Okay. And the thing about cubes, you can have, so your solution can be negative and positive. Okay. All right. So what we want to do, like we did on the previous example, we're going to pick some points. In this case was, if it's an odd function, if it's an odd root, we can use, we're going to get negative and positive answers. Okay. We can't have negative answers if it's, if the root is even. Okay. So we're going to do, we'll do 8. All right, we'll do 8. And so the third root of 8 is 2. Then we can do, of course, we can do 1. We can do negative 8. So that'd be negative 2. Negative 1 would be negative 1. Because if you think about it, if you have a negative 2 times a negative 2 times a negative 2, that's going to give you a negative 8. So if I take the third root of negative 8, I'm going to get negative 2. Now, of course, if we put 0, we got 0. And then if we put negative 1, we put 1. I'm sorry. If I put 1, we get 1. If I put 8, we're going to get just positive 2. All right. So when we graph this, it's going to look like this. Although it's an odd function, right? So we know about what the end behavior is going to look like. So I'm going to do all right, so 0, 0 will start the origin. Then 1, 1 would be right here. And then what we have, what, 8, 2 is going to be right here. Then negative 1 is negative 1. 8 is be negative 2. So the function is going to look like so. So that's your function. Anytime you have an odd root, your behavior is you're going to have negative and positive answers. Okay, so any questions on this one? Let's see. All right. All right. So that makes sense? So what we're going to do now, we got to talk about the shifts. Okay, when we did quadratics, we did the shift up and down, left to right. You're going to do that for every function you have, regardless of how the power is. It's the same basic principles. Okay, so this is for a odd function. We did an even function earlier with the square root. Now this is the third root. So now we got to talk about what the shifts look like. So we're going to have so what you want to do, how you just think about it. This is cube, right? So just find your perfect cubes, because if it's not a perfect cube, you're gonna have some decimals. So try your very best not to have any decimals. So I know that if I do a -2 cubed, I'm gonna get -8, which is a whole number. I know if I do a -1 cubed, I'm gonna get -1, which is a whole number. Then of course I can plug in 0, 0. So what you want to do, you're doing your perfect cubes, or you're doing your perfect squares, or your perfect to the 4th power, whatever that is, that's what you want to look for. And so when you do it, these are your points. And then you can just connect them. All right. Instead of having decimal points and you trying to guesstimate what the answer is, okay, try to keep it positive. And when you do it, when you do this line right here, it's going to hit the points where if it was a decimal. So you'll be fine. All right. Okay. All right. So I'm gonna go ahead and move on. But yeah, this is what it looks like. Remember when we talked about if it was an odd function, if this is a positive value in front of here, which is actually a +1, we said that as x goes to the right, goes to positive infinity, this should be going positive infinity, right? Then if x is going to negative infinity, the function should be going to negative infinity. All right, so I'm gonna go ahead and erase this, and we gotta talk about the shifts. Okay. So we're gonna start with square roots. Okay, so you have your formula here. You have y is equal to all right. So what you want to do here, this k, whatever is outside the radical, so this is going to be your y direction. All right, so whatever's out here, you're going to graph this as usual. It's your parent function. Then you're just going to shift it up, whatever k is, in the y direction. So if this is a +3, you would do your regular parent function. You would graph that. Then you would just add whatever this k is. If this k is positive, you will move it up that graph that many spaces. If it was if k was negative, you will move it down that many spaces. So now, if it's inside the radicand, you're going to be like we did you're going to shift in the other direction. So in other words, you're going to set whatever this number is, h, you're going to set it equal to 0. Okay. So for example, if I had x plus 2, set that equal to 0. So my shift would be x minus 2. All right. So if it's up under the radicand, you're going to shift in your x. So you're going to shift. You're going to go in your x direction. I guess I could put shift up here as well. All right. So if you're going to do this one, if you have a negative outside, so you have a negative outside the radical, you're going to, it's going to be a reflection it's going to be a reflection about the x-axis. And then if it's on in the radicand, it's going to be a reflection about the y-axis. All right. So you get that? All right. So what we want to do here, we're going to talk. So we're going to do these three things to this graph. Okay. So let's look at. So we're going to put this 1. We'll let this be 2. Let this be 3. Let this be 4. And we'll put rules here. All right. So this. So let's look at. See if we have a function. Y is equal to the square root of x plus 3. All right. So we'll normally come here. We got the parent function, which is y, the square root of x, right? Okay. So I'm going to let this be y1. This will be y2. Okay. All right. So what I want to do here, I got my x's. I have my y's. Got my y1. And I have my y2. All right. So remember, this is a even. So this is a even root. So we can't have any negative numbers. So what we can start with is 0. So if we plug in 0 for the parent function, okay. So that'll be 0. This is also be 0, wouldn't it? So this will be 0 plus 3. Then if I come here, if I plug in 1 for the parent function, so that's 1 parent function, this is 1. Now this is 4. So if I plug in what 2, well, I need to plug in 4 because I need the perfect square. So the square root of 4 is 2, right? Then this is, so this 2, now we have, so what did I do for here? Okay, so sorry. So if I plug in 1, so that'll be 1 plus 3, which is 4. If I plug in 4 here for the parent function, the square root of 4 is 2. So that'll be 2 plus 3, which is going to give me 5. Now, and then if I plug in 9, which we don't have to, we can just use these points here. All right. So when I graph this, so I have 1, 2, 3, 4. All right, and then my y direction. I have 1, 2, 3, 4, 5, 6. So that's 1, 2, 3, 4, 5, 6. All right. So when I do that, so I add a 3 to it. Now I'm going to my I'm going to right here. I have 0, 3. Then now I have 1, 4. And then I have 4, 5. So that is going to be the square root of x plus 3. Now, if I do the parent function, it would be 0, 1, 1, and 4, 2. So all I did was took this parent function, All right, so all I did was took the parent function, y equals square root of x. All I did was shift it up 3 spots. It's the same graph, I just shifted up. All right, are there any questions? So we've got rule 1 out the way because this 3 out here is positive. Now, if I were to make this a negative number, say if this was -2, it would just shift down. It's the same graph, it would just go down 2 spaces. All right. I need some feedback, folks. You need to talk to me. So does this make sense? Okay, so Mark Charles. Okay, so if you get this right here, if I come down here and I do, so this is -2, this is -1. So if I come down here and do this, then so that's 1, 2, go here, and then this is going to be down to 0. This right here would be the square root of x minus 2. Shamaris, okay. You want me to put up problem number 23 again for you since you got here late? Oh, you know what? You can watch the video. You can watch the video after I'm done. Okay. All right. Good, Mark Charles. So what we're gonna do? So we've done this one. The number outside the radical you're gonna shift. That's gonna shift your function up or down. So now we got to talk about what's gonna happen when you have a number up on the radical and you got to do the shift. And we're going to keep the parent function up. So now we're going to do, so let's do y. Now y2 is going to be x minus 1. Okay, so that means that we're going to set this equal to 0. So x is equal to 1. So in other words, we're going to shift everything to the right. All right, so we're going to plug our points in like we normally do, and we're going to graph it. Let me move it over a little bit so we have room to graph. All right, so we're going to plug in. So we'll let y1, and then we're going to come here, and we're going to do y2. So we're going to do the parent function so you can see the shift. So in the parent function, I'm going to put, oh, you know what? Since this is going to be 0, we can't start at, we have to start at x is equal to 1. Okay. So that's going to be 1, and that's 0, and then we want to do 5. And we're going to do, what's another? So perfect square is 4. So we have 1, 4, we have 9, right? Okay, so for this one, we have to do 10. All right, so those are our points. All right, so we're going to eliminate this right here. We'll just do y2. All right, so if I come here and I plug in 1, So that will give me, if I plug in 1, put it over here. If I plug in 1 minus 1, that's going to be 0, right? So this will be 0. If I do y is equal, plug in 5, so 5 minus 1 is going to be the square root of what, 4, which is going to be 2. And then if I plug in 10, 10 minus 1 is 9, and the square root of 9 is 3. All right, so now we're going to graph it. Trying to make sure I have enough room. Oh, when I graph it, you'll see. You'll see, Grace. You'll see it when I graph it. Okay, so when I do this, so I have what? 1, 2, 3, 4, 5, 6. I need some more room. Mm-hmm. All right, so this is the parent function. Now we're going to do the function y minus 1. All right, so we're going to go over to 1, 1, 0. Then we'll go over to 5, 2. And then we're going to go over to 10, 3. So when we did this, so we did the parent function. Okay, this is the parent function, but when we put x minus 1, we got to set that equals 0. So when we set that equals 0, that's the direction that your shift's going to go in. So we take x minus 1, set it equal to 0, it's 1. So that means from the parent function, I have to shift this whole function over 1. Did you see? Did you get it now, Grace? Now, if I were to put a plus 1 up under the Radicand, then this graph would just shift back 1. So that's why I mean over here, rule 2. Okay, if you have a number up on the radical with the variable, it's going to shift it in the x direction, either to the left or to the right. But what's up? You'll take the Radicand, set it equal to 0, and that's the direction of your shift. And that's going to be how many spaces that you're going to make your shift. We're good? All right, wait for some feedback. Okay, thank you. All right, so we're gonna move on. So we talked about this one. We talked about if it's outside the radical. Outside the Radicand, what the number is, shift y direction. Okay, if it's inside the Radicand, we're gonna talk about shift right to left. Now we got to talk about the reflection. All right. So what we want to do, we're going to do y2 is going to be, we're going to do a negative square root of x. All right. Okay. So we're going to come here. We're going to do x. We're going to do y. All right. So we have to start at 0, right? So I'm going to put y1, y2. All right, so we got 0. We already know if we plug in 0 here, we'll get 0. We put 0 here, we'll get 0. Okay, so we're going to do 1. The square root of 1 is 1. The square root of 1 is 1, but we have a negative on the outside, so that's negative 1. Then our perfect square is 4. We take the square root of 4. That's going to give us 2. But if we take the square root of 4 here, we get 2. We got a negative in front, so that's negative 2. So these 3 points will be fine. Okay, now, so what we want to do here, we're going to graph it again. So we got 1, 2, 3, 4. 1, 2, 3. So we only need a couple of points. All right, so I'm gonna go ahead and do the reflection. Well, we're gonna do the parent function first. So that'll be 0. That's gonna be 1, 2, 3, 4. So that's gonna be 1, 1. And then we're gonna do 4, 2, right? So we have 4, 2 here. That's your parent function. Now, since we put a negative here, we're gonna have what, 0, 0. Then we have 1, negative 1. And then we have 4. So if we go down negative 4, we have a negative 4, what, 2? Oh, we got 4, negative 2. My bad. So we got 2, negative 4. 4, negative 2. And then it should look like this. And so that's going to be a negative square root of x. So if you notice, they're mirror image of each other, and they're going to be in your x-axis. It's the mirror that they're looking at. So this is my parent function. I'm looking in the mirror, and so this is my reflection. Make sense? So if I drew this perfectly, this would be the exact image of this. We're good? So we talked about the reflection. Oh, it is. It is, Jamar. That's why I was trying to show you the basics in the previous lessons during the semester, so it can help you out. Mark Charles, I'm doing examples now. All right. These are the examples. Okay. All right, but we can do some though. All right, so now let's look at what's going to happen if you're going to do a reflection when you have a negative up on the radicand. We're gonna see what happens. All right. So let's do. So we still use the parent function. So let's do y. So there's y2, and that's going to be a negative. So we got a negative up under the radical. Okay. So what we want to do here, we want to do x, y1, and y2. All right. So we can put 0. This is 0. This is 0. Okay. So what we want to do now is we want to use Since this is negative and this is a even root, we want to use negative numbers. So I guess I should go this route. So we're going to erase this. So we need to do -4 because, so reason why I want to use -4 is because we have the square root of a -4. That's going to give us the square root of 4. And we know that's 2, right? So this is going to be 2. All right. So now if I do, so now I want to put in -1, because if I do a negative is there first, plug in -1, that's going to give me the square root of 1, which is 1. All right. So now I want to use 0. So if I plug in 0 here, we know that's 0. So now we're going to graph it. Try to make it fit the page, not the page, the board. So that's going to be 1, 2, 3, 4, -1, -2, -3, and -4. All right. So if I do -4, so we know if I do my parent function, it's going to look like this: 0, 1, 1, 4, 2. Right. So it's going to look like this. Ooh, that's a little ugly. Sorry. It's going to look like this. All right. So now if I got a negative, the negative on the radical, so that's going to give me -4. So I'll give me a -4, 2. Then a -1, 1. Then, of course, this is 0. Same height. Okay, so you notice that it's reflecting about the y-axis. And so that's going to be your rule. So that's the fourth rule. Now we have to do what's, if you understand this, the next 2 rules is horizontal shift and vertical shift. So we're going to have horizontal shrink, horizontal stretch, vertical shrink, vertical stretch. That's what we'll do next. So does this make sense right here? So I give you a minute for a response for this one. All right, so I'm gonna move on. Our next 2 rules. So I'm gonna go ahead and erase this section right here. So we have 2 more rules that we have to do. All right, so I'm gonna go ahead, like I said, I'm going to, well, I guess I could keep them up here. Okay, so if I do, so we got rule 5. So that means if we have this, we have a number outside of our radical. Okay, that's going to be your vertical stretch or shrink. So if you have rule 6, if it's up under the radical, that means that you're going to have a horizontal stretch or shrink. Okay. So once we'll get these 6 done, then we'll do a combination of them. We're good? All right, so I'm assuming that we are. Okay, so what we're going to do, this is the parent function. Okay, so what we're going to do, we're going to do the 5th rule. We're going to do a vertical stretch. So we're going to put 2 the square root of x. All right. So if we're going, so what we're going to do, again, we're going to pick some points. Remember, since this is an even root, you can't use negative numbers. All right. So what we're going to do here, we're going to do x, and we're going to do y1, and we're going to do y2, and we're going to pick some points like we normally do. So this should be 0, 1, 4, because I'm picking my perfect squares. So for my parent function, this is 0, this is 0. Now, when I plug in 1, we know the square root of 1 is 1. Then we got to multiply that by 2. So that's 2. So it's going to double each time. So if I put 4 up on the radical, square root of 4 is going to be 2. 2 times 2 is 4. So if I use the parent function, it's just 2. Square root of 4 is 2. Now I got to multiply by 2. So that's going to be 4. All right. So now I have to graph this. So I'm going to graph the parent function, and I'm going to graph so in this case, since this is 2 is greater than 1, greater than 0, that means this is a vertical stretch. Okay. All right. Okay, so what I want to do here is we're going to graph both the parent function and the shift. All right. So the parent function, we will get 0, 1, then we have 4, 2, right? So then we're just going to do like so. All right. Now, so this reason why they call this a vertical stretch, because when we graph this, of course, we got 0, 0. Now, instead of having 1, 1, we have 1, 2. So we doubled the value of y. Then instead here for this second function, which is the vertical stretch, instead of y being 2, now y is 4. So in other words, we just stretched we just stretch this function in the y direction. So in other words, this is 1, 1, and this is 1, 2. This is 4, 2, and this is 4, 4. So we just stretched it in the y direction. Okay, so if k was negative, remember if k was negative, if k was negative, remember if it's negative on the outside here, that means it's going to be reflected about the x-axis. So if this was -2, it'll be a stretch and a reflection because you got a number outside, that's your k, then you have a negative, so you've done two things. So if this is a -2, you will have a vertical stretch. So since this is negative, you will have a reflection about the x-axis. We're gonna get to that in just a second. All right. Okay. We're good. So now we're going to do a horizontal shrink. All right, so I'm going to erase this one. Well, you can see that's a vertical stretch. Now I need to show you a horizontal stretch or horizontal shrink. We'll do that. All right, so we've got this up. So we've taken care of this. Okay, now bear in mind we still have the parent function. So we're gonna do a horizontal stretch. So we're gonna do so we're gonna do 1/2 x. You with me? Okay, so what we want to do, we're gonna come here again. We're gonna pick some points. So we're gonna do 0, and we're gonna do 1, and we're gonna do 4. Just those 3 points. This is the parent function. This is going to be our shift. Okay, so if I plug in 0 here, parent function, I get 0 here, right? So if I plug in 1 here, then if I plug in 1 here, that's 1/2, and the square root of 1/2 is going to be what? What's the square root of 1/2? So we take the square root of 1/2. So that's going to give us 0.7. And then we plug in 4 here. That's going to give us what? 2. Then the square root. So half of 4 is 2, and the square root of 2 is going to give us what? It's going to give us about approximately 1.4. All right. So now let's graph this and see what it looks like. Okay. All right, so our parent function, we have what? 0, 0, and then we have 1, 1, and we have 4. Okay. All right. All right. So this is our parent function. All right. Now we want to do what we have 1/2. Okay. So we have what? 0, 0 again. Then we have 1.7. So I'm going to say 0.7 is about right here. And then we have 1 and we have 1.4. I'm going to say it's about right here. All right. So the reason why they call this a horizontal shrink, because to get to so in other words, the reason why I call it horizontal shrink, so in order to get to that same height, you're going less the distance. Then to get this height, so we got 1.42. So if I wanted to go to get to this point here, if I go my x value is smaller, and I'm going to get there. I get there at a shorter time. So that's why they call it a heart. So I'm sorry, that's a horizontal stretch. It's a horizontal stretch. So did I graph this right? So I have 1, and then that'll be 1/2. So So I'm sorry. So it's a horizontal stretch. Okay, so I would have to go out further. Okay, so in order to get 1, and this is a horizontal stretch. I'm sorry. So in order to get 1, I have to make this bigger. So in order for this to equal 1, shouldn't I have to make this equal to 2? So in order for this to equal 2, shouldn't I have to make this equal to 8? Because half of 8 is 4, and the square root of 4 is 2. So this is a horizontal stretch. Because if you notice, when I plugged in 4, I'm down lower. Okay. Then from going to 1, I'm down lower. So in order for me to make this work, to get the same value for here, my x has to be bigger. So in order for me to get 1 here, I need this to be 2. So in order for me to get 4, I need to make this 8. So it's a horizontal stretch. So in other words, I got to go out further to get that same height. So that's why it's called a horizontal stretch. All right. So now, only thing we have left is we have to do a combination of the two. Okay, so I'm gonna do a problem like so. We're gonna do a combination of the two. So we're gonna do y is equal to all right, so if we're gonna do this, so here we got a negative. So if we got a negative, that means it's gonna be reflected about the x. About the x-axis. And this is going to be a shift up 4 in the y direction. All right. So what we're going to do now is we're going to come here and we're going to go here. We got 1, 2, 3, 4, 5. All right. So we're going to do the parent function. So if we do the parent function of this, we should get 0, 1, 1, 4, 2. All right. All right. So remember, we got to do a reflection of this, right? Okay. So we got a reflection by the x-axis. You know what? Okay. All right. So you know what? I need to redraw this. Sorry. All right. So the parent function is going to be 0, 0, 0, 1, 1, 4, 2. So that's the parent function. All right. So this is the square root of x. Now we got to do this. So we got to do a reflection. So do a reflection of this. This would just be, I'm just going to trace it. I'll do the very last part of it. The final graph, I will do that. Well, I'll do it in another color, but I'm doing this reflection first. So I have, so this would be 1, then I go over to 4, negative 2. Okay, so that's the reflection. All right, now I got to shift up 4. So I got to go here. So that's going to be 1, 2, 3, 4. And then here, this is negative 1, negative 1. So I got to go here, 1, 2, 3, 4. Then here, so I got a negative, so I have 4, negative 2. So I go from here, I got to go 1, 2, 3, 4. So this is going to be a negative x plus 4. And this right here is going to be a negative square root of x. This function here. So I had to do two. I had to do two rules based on this: reflection and shift. Okay. Any questions? I'm just grafting y1 just to show you what the parent function looks like. And then these two would just be the transformations. So no, you do not have to do the parent function, but you need to know where the parent function starts from. I was just showing you. That's why I wrote the parent function each time. So when you do your reflections or do you do your shifts, you know why it should be the way it is. But no, you do not have to write this. You do not have to write the parent function. I would just use the parent function as a reference so you can see why the function is ending up where it is. So no, you don't not have to write the parent function. Actually, if you wanted to, you didn't have to write all three of these. You could have just went to the end. But you have to know that this is going, you got to do your reflection, and then you got to shift up. Or you could shift up and do your reflection. It doesn't matter which direction that you go in, but you just have to do those two things. You have to cover those two rules. Okay. So basically, that's all we're going to cover for this section. The things that I put on the blog to do yesterday, you could do that today. Because remember, we spent the whole time doing the previous lesson, so we didn't have any homework to do. So I want you to do this lesson 20 tonight, and I'll put an answer key on the blog, step by step, showing you how to do it. All right, so for right now, we're done. Just go to the blog and look for those questions. Look at the questions. And I'll see you all tomorrow, if there's no more questions. Okay. All right, I'll see you. I have to get ready for my AP Stat class. Thank you. You too, Jamar. And go back and look at the beginning of the video so you can see problem 23 worked out. Okay.